Dear students, in this session we are going to discuss polymorphism in C++. Here polymorphism is actually a Greek word. It is derived from the Greek language, which means many forms. It is an ability to it is an ability to be in many forms. So as I said, an ability to be in many forms is nothing but here we can create the function which can play multiple roles, and we can also create some operators so which can play different roles in different cases. So here using this polymorphism we can define several functions which performs the different functionalities based on the type and based on the number of arguments, and we can also assign some new meaning to existing operators, and we can also link these member function to objects at a runtime. Let us try to understand how this polymorphism can be achieved and what are the different types of polymorphism. And if you see the different types of polymorphism, there are basically two types of polymorphism. This polymorphism can be compile time polymorphism as well as runtime polymorphism. And this compile time polymorphism is achieved by overloading functions and overloading operators. That means the compile time polymorphism can be executed by function overloading and as well as operator overloading. Next, runtime polymorphism is achieved by using the virtual functions. So let us try to understand what is compile time polymorphism. The compile time polymorphism, as I have said already, the compile time polymorphism is achieved by overloading functions, member functions, or overloading operators. And let us try to understand what is meant by function overloading. So we are already familiar with the functions. A function is a reusable block of code that is invoked and that is executed whenever you invoke it using an object. Here the function is a member function or a method in a class, and here the function overloading is a process of defining the multiple functions all with the same name but with a different number of arguments and different types of arguments. So when we define multiple functions with same name but with a different number of arguments and different types of arguments, so that is called as the function overloading. And this function overloading is actually done in a class. That means, so we can have the multiple member functions with the same name but with a different number of arguments and different types of arguments. And so this compile time polymorphism is actually achieved by overloading the functions. And when we have overloaded functions in a class, and the appropriate function will be invoked and appropriate function will be called, and this will be linked to the object, and this information will be automatically decided by the compiler at compile time. So when we invoke overloaded function, that means whenever we have the multiple functions with the same name and the different number of arguments and different types of arguments, and when we invoke a function, when we invoke a member function, the compiler will actually try to match the number of arguments and types of arguments if there is any match, and that particular function will be linked and that particular function will be invoked. That means the compiler knows this information, which function to be executed and which function to be linked to the particular object, at compile time itself. This information will be completely known to the compiler at compile time itself. So that is why it is called as a compile time polymorphism. And see, this compile time polymorphism is also called as early binding, static binding, or static linking. It is also called as early binding because so before running the program itself, at the compile time itself, the compiler knows the full information to, that means so to which function the object should be linked and which function should be invoked by matching the type of arguments and the number of arguments. So it will pre-decide which function should be executed, which function should be linked. So that is why it is called as early binding. Early binding. It is also called as the static binding or static linking. So let us see a sample code. So in this code, in this example, so I have a class, the class name is shape, and we have two public data members. Those data members are length and breadth, and I also defined a method called area method, area, void area. Area is a member function. And see, we have defined one more function with the same name. The name of the function is area itself. That means in this case we have defined two member functions with the same name. The name of this member function is area itself. But there is a difference. Their prototypes are different. Here prototype in the sense the type of arguments and the number of arguments are different. See, in the first case, the area method takes only one integer type argument, and in the second definition of the area, function, it takes two arguments. It takes how many arguments? Two arguments. One integer type length and another is int b for breadth here. That means this function is overloaded. So that means whenever we define multiple functions with the same name but with a different number of arguments and different types of arguments, this is said to be overloading, function overloading. It is also called as method overloading. And see, that means in the first case it accepts only one argument and it finds the area of the square, and in the second case it is going to accept two arguments and it is going to find the area of the rectangle. So it is taking two arguments, length and breadth, and using those arguments it is going to calculate the area of the rectangle. And see, in the main function we are creating an object of shape class. Here square is an object of shape, and we are invoking the area method, area function, with only one argument. See, square dot area, it will invoke the area function. So here the compiler at the compile time, it will try to find the exact match for this function call. See, first it will try to find is there any function by the name of area that accepts only one argument, one integer type argument. See, since there is one member function whose name is area, and here the case is also same, the case area, the name of the function is matching, and it is also trying to find the number of arguments are matching or not. Yes, we are passing only one integer type argument, and here also it is accepting only one integer type argument. See, because it has an exact match with the first version, that is first area function, which accepts only one argument. Here the square function, the square object will be automatically linked to the member function, that is area with only single argument. So that means it will invoke the first area function, and this 10 is copied into side, and it will find the area of the square box. It will print the output area of the square box is 100. And in the second case we have created one more object of shape type. The object name is rectangle. Rectangle is an object of shape type, and rectangle dot area of, so we are passing here two arguments 10, 20. So in this case the compiler at the compile time, it will try to find the exact match for this function call. And since there is a function, member function named area, which accepts two arguments, the two arguments of integer type. See, it has got one exact match for this function call. It will link this object with this function only, because we are passing two arguments and there is a function which accepts 2 arguments. So hence it has got the exact match for this function call. So it will link this object with this particular area function which accepts 2 arguments only. So that means it will link to the second version of the area, and it will automatically calculate the area of the rectangle by using this L and B values, see length and breadth, and it will print the output area of the rectangle box is 200, because here the passed arguments are 10 and 20, 10 into 20 is 200, and it will print area of the rectangle box is length into breadth values are 10 and 20, 10 into 20 is 200. So that will be the output. So that is here the linking procedure, the object and the appropriate functions are linked. So this linking and to which function it should be linked is decided at the compile time itself. So in the decision, that means when this object has to link a particular function, first it will decide which function it should call. So that is decided by the compiler at the compile time by matching the number of arguments and types of arguments. So in the first case, because we are passing only one argument, and it will search for only that particular area function which accepts only one argument, and it will link to that particular function. So this linking procedure is actually done at compile time. So that is why it is called as compile time polymorphism. Next, another way of achieving the compile time polymorphism is operator overloading. Similar to function overloading, we can also overload operators. Here operator overloading is nothing but redefining the meaning of an existing operator. See, every operator has a particular purpose, however we can change its purpose, however we can change its objectivity, we can change its functionality by overloading, by giving an extra functionality. For example, here we have left shift operator, double less than. It can also be used as an insertion operator in the output function. For example, it can be used along with the cout function for sending this string to the output stream. Cout and this insertion operator, double less than is an insertion operator which sends this string, double quoted string, that is hello, to the output stream. That is, this double less than performs two different functions in two different cases. It can act like a left shift operator in one context, and it also work as an insertion operator in another context. When it is used with the cout function, it acts like an insertion operator, and it can also be used as a bitwise operator, that is left shift bitwise operator. That means this operator is overloaded. It has two meanings in two different cases. That is, we can overload any existing operator, so by assigning some new meaning, that is called as overloading an operator. So we can overload almost all the operators in C++ except some operators. See, we cannot overload this dot operator. Member access operator cannot be overloaded, and we cannot overload this pointer to member operator. We cannot overload the scope resolution operator. We cannot overload this ternary operator, and even we cannot overload this preprocessor symbol, which is hash, and double hash symbols cannot be overloaded. Except these operators, we can overload all other operators. We can overload arithmetic operators like plus, minus, and unary operator, unary plus, unary minus, increment operator, decrement operator. We can overload almost all operators except these, except this dot operator, member access, and pointer to member, and scope resolution, ternary, and the preprocessor operator, that is hash symbol. This cannot be overloaded. And now let us try to understand how to overload an operator. Here any operator, any existing operator can be overloaded by using an operator function. And here the operator function must be a non-static type, that must be a non-static member function. And here we have the syntax of using the operator function. if you want to overload any operator, first we need to write the return type and followed by operator keyword and followed by the symbol that you want to overload, and inside the parenthesis you can write any argument list, and inside this braces you can write the code for overloading that particular symbol. That means here the return type can be any type, any primitive type, or it can even be any class type, and here operator is the keyword and symbol is any symbol or any operator that you want to overload, and inside this parenthesis you can write any argument list, and the code can be any code, so that changes the meaning of that particular operator. And see, here we are going to overload unary operator. So we can overload any operator, unary and binary, but for instance we are overloading unary operator in this case. See, to overload any unary operator, obviously we have to use an operator function, but here operator function and this operator function requires no argument if it is a member function of that particular class. So if it doesn't belongs to the member function of the class, that means if it is a friend function, it should take one argument. But in this case, I am using the member function. That means here the operator function is going to be a member function of the class and it takes no argument. So in this example, we have a class named unary and it has two private data members n1 and n2, and it is called as a constructor. I hope you are familiar with constructors. The constructor is used to initialize an object. It is going to accept two parameters. It is a parameterized constructor. It accepts the two values and assign them to the two data members n1 and n2 respectively. Next, so this highlighted portion is the operator function to overload one symbol. Here we are going to overload one symbol, unary minus. This unary minus is a symbol, so actually it changes the sign of any primitive type like integer value or a float value to negative. It is used to change a numeric value sign to negative, but in this case we are overloading it in such a way that it is going to change the sign of two values at a time. It is going to change the sign of two values at a time into negative. That means it is going to accept only one object, that is one argument, but in that argument, so it may contain the two values and those values will be automatically assigned a negative. That means we are giving a new meaning to a unary minus. This unary minus is going to change the sign of the two numerical values at a time. So in this way we are assigning a new meaning to this unary minus. Next, we also have a member function named show unary. The show unary will display what is there in this n1 and n2. And next, in the main method, we are creating an object of unary type. The unary is the class name and my unary is an object. And we are also passing two arguments, and in this case it automatically invokes the parameterized constructor. That means my unary 1 is an object and this object will be automatically initialized with 10 and 20. And see, here we are displaying what are the values in that my unary 1 object before applying the unary, that means overloaded unary minus, and after applying the overloaded unary minus. See, before applying this unary minus, to see what is there in that my unary data members, I am invoking show unary, and my unary 1.show unary will automatically display. So this output before applying the unary minus, the n1 and n2 values are 10 and 20 respectively, because we haven't applied that overloaded unary minus yet. Next, we are applying my unary 1, that means we are applying unary minus operator on my unary 1. So when you apply this minus operator on an object, it automatically invokes an operator function. So the operator function is going to overload minus because we have written the code accordingly. See, when we apply the unary minus on one object, it automatically invokes the operator function and automatically it will pass those values, that means n1 and n2 values through this object itself. here the objects n1 and n2 are automatically assigned minus sign, and they are again assigned to n1 and n2 respectively. And after applying this unary, we are showing that unary values, that means those member values, data member values, by calling this show unary method. See this in the output, you will get what? After applying the unary minus, you will get n1 equals to minus 10 and n2 equals to minus 20. So that is how we are changing the meaning of an existing operator. So in this case, we have changed the existing operator unary minus in such a way that it is going to change the sign of two data members of the object to negative. That means we have overloaded this operator, we have assigned a new meaning. Generally, the unary minus can be applied on only one operand, which can be any numerical value. The numerical value sign will be changed to negative. But in this case, we have overloaded that unary minus in such a way that it is going to change the sign of the two data members of that particular object. So that is how we can overload a unary operator by using which function? Operator function. This is unary operator overloading. Next, similarly, we can also overload the binary operator. We can take any binary operator. See, in this example, we are going to overload one binary operator, that is arithmetic operator plus. Usually the plus is a binary operator that can be applied on two operands, and it produces the sum of the two numbers. But in this case, we are going to overload the binary operator. We are going to overload the binary operator plus in such a way that it is going to add two complex numbers. Generally, it can be applied on the two numerical values, but when it is applied on the two numerical values, it will produce the sum of the two numbers, which is again a single number. But here we are going to overload this binary operator plus in such a way that it is going to add two complex numbers. We know the complex number is the complex number contains two parts, the real part and imaginary part. That means it is going to accept two complex numbers, and which will add them, and it will be returned by this binary operator. See, in this code we have a class named complex, and with two private data members. The private data members are real and imaginary. So real and imaginary parts. So real is integer type and imaginary image is also integer type. And we also have a public member function. It is actually a constructor. Complex is a constructor. So constructor is a member function of a class which is used to initialize any object. And if you see this, it is going to have some default arguments. So it will automatically have r and I values to zeros. That means it will automatically initialize these data members to zeros initially. It is a default constructor. Next, here highlighted portion is the operator function. We are defining one operator function for overloading one symbol, that is symbol is binary plus. So to overload any operator, we have to use an operator function, and it is going to return the complex type. It is going to return complex type. It is a class type actually. So the return type is the complex, and the symbol I want to overload is plus. Next, it also takes one argument. That argument is again complex type object reference. Complex type object reference. That means here the plus is an operator that can be applied on complex type objects, that can be applied on two complex type objects, that can be applied on complex type objects. So this operator function is going to take one argument of what type? Complex type. See this, inside this operator member function, operator function, we have a new object called res. It is a result of complex type, and we are extracting the real part and imaginary part, the real part and imaginary part of that argument. That means the object object data member, that is the real part and imaginary part, and adding it to the real part. That means the real part of the one complex number is added with the real part of the another complex, and the result is stored back to the real part of the result object. And in the second case also, we are accessing the imaginary part of the object, that is argument, and next we are adding it to the imaginary part of the another object, and finally this sum is added to the imaginary part of the new object, that is result. Finally we are returning this object, that is complex type object. That means here it is going to be applied on two complex type. It is going to be applied on two complex type objects. See, in the main method you can observe this. So here C1 and C2 are the two complex type objects, and they are automatically initialized to 12, 6 and 4 and 2 respectively. Here the 12 is real portion and 6 is the imaginary portion, and C2 contains two portions here, 4 and 2. 4 is the real part and 2 is the imaginary part. Here C1 plus C2 is nothing but, when you write C1 plus C2, it automatically calls this operator function. It automatically invokes this operator function. And when it calls this operator function, here the C1 and the C2, so this C1 and C2 data members will be automatically added, and they will be stored back to this result which is a complex type. Finally, so it is returning that result object, and that returned result object will be assigned to C3, and C3 will contain the addition of these complex numbers. So finally we will have the result of this addition of the two complex numbers in the C3, and finally we are printing that those complex number values, that means the real portion and imaginary part, by calling which method? Print method. The print method will print the real value, that means the real portion of that particular object, and as well as the image data member of that particular object. The C3.print will give you this output 16 plus I8, because 12 plus 4 is 16 and 6 plus 2 is 8. So this is how we overload a binary operator. Next, let us talk about the runtime polymorphism. We have already seen compile time polymorphism. The compile time polymorphism can be achieved by overloading the functions and overloading the operators. Now let us talk about the runtime polymorphism. A runtime polymorphism is also called as dynamic binding or the late binding. It is also called as a dynamic polymorphism, dynamic binding or the late binding. So in this type of polymorphism, the linking process is actually done at runtime instead of the compile time. The object and the appropriate function will be linked at runtime. That means the compiler will not decide to which function the object should be linked at runtime, not at the compile time. So this decision will be kept pending until the program is running, until the time of running the program. That means the compiler doesn't know, so to which function to be executed and which function to be linked to the particular object. The compiler doesn't know the exact information and to which function to be linked and which function has to be executed. So this linking procedure will be actually postponed till the running of the program. So that is why it is called as a runtime polymorphism. And see, this runtime polymorphism is achieved by overriding the function overriding. So let us try to understand what do you mean by function overriding. The function overriding is a process of redefining the base class member function in the derived class. That means when we have a member function in the base class and we are redefining the same function in its derived class, that is called as overridden. That means we are redefining it again in the derived class, that is called as overriding, function overriding. That means in the function overriding, if we define some function in the base class the same name should be in the derived class. We are defining it with the same name, and the prototype should also be same. The signature should be same. That means the number of arguments and type of argument should be same. And the function names should be same, and their prototype should be same. Then only it is said to be overriding. That means when we have a base class function and the same function is redefined in the derived class, that is called as function overriding. See, in this example, we have a base class named base itself, and we have defined one show method, and the same show method is redefined in the derived class. See, if you see, the name is same and its prototype is also same. There are no arguments, and here also there are no arguments, but only the definition may be different. The definition in the sense the body may be different, except the body, everything is same. The prototype is same and the function name is same. And see, in this automatically the base class method is hidden. The base class method is hidden. Here in the main method derived d, we are creating an object of derived class, and d dot show will invoke only the show method of which version? Derived version. So which version of the show method is invoked? Only the derived class show method is invoked, because we have created the object for a derived class. So this is function overriding. Thank you.